Hi dear students, welcome to Mandawad Maths Academy. Now today we are going to start the new topic, rank of a matrix. So what is meant by rank of a matrix? Where we are going to use this rank of matrix. So what is meant by rank of matrix? First we see the definition. So many definitions are available. So let us consider, suppose a positive integer any r that said to be the rank of matrix which will satisfy these two conditions. So first condition, if there exists at least one square submatrix whose order is r and whose determinant is not equal to 0. So this is very important. Suppose we have given one matrix. So that order whatever given, suppose I take m cross n or m by n. So there exists one submatrix whose order is r. Whose order is r and determinant of this matrix is not equal to 0. So this is the first condition. What is first condition? If there exists at least one square submatrix, means one square submatrix in this given matrix, so whose determinant is not equal to 0. And second condition is, if the matrix contain any square submatrix whose order r plus 1, the determinant of every square matrix whose order is r plus 1 should be 0. So you can remember, suppose this is the rank of a matrix, rank of this given matrix is r, then we check about the r plus 1. What is the determinant of this r plus 1 matrix? That should be 0. So you can remember here, suppose r is said to be the rank of matrix, the determinant of this matrix is not equal to 0. And we increase by 1 this r plus 1. We take determinant of this matrix r plus 1, that should be 0. This is compulsory. So therefore this r is called as rank of matrix. So this is the first definition. Next you can remember in simple way, the rank of matrix you can find out by using echelon form. Okay. So what is the rank of matrix? Simply you can remember number of non-zero rows in the echelon form. So that nothing but the rank of matrix. Is it clear? First definition, by using determinant can define rank of matrix. Second definition, rank of matrix is nothing but number of non-zero rows in the echelon form. So what is echelon form? You can see in the next class. Okay. Next, what are the note, or you can remember the properties of rank of matrix. The rank of matrix is generally denoted by this row of A or the A of R. Generally you can use maximum times row of A. So this is the symbol of the rank of matrix A. Every matrix will have rank. Means we have given any matrix that should be ranked. That should have rank, means matrix, every matrix will have rank. You can remember, rank of matrix is unique. Unique is nothing but we have given, suppose matrix A, it has only one rank, only one rank. One rank is nothing but it has only unique rank. So there does not exist 2, 3, 4 ranks. Okay, you can remember. If rank of A is 0, if rank of A is 0, so that matrix A is called as null matrix or 0 matrix. Means all the entries of the matrix are 0, so then rank of that matrix is 0. And if rank of matrix A is 0, so that matrix is called as null matrix or 0 matrix. Next, if A is of order m cross n, the rank of A that should be less than or equal to minimum of m comma n. Suppose for example, I take a matrix A whose order is 5 cross 6 or 5 by 6. So what is the possible rank of this A? This A that should be less than or equal to minimum of this 5 comma 6. What is the minimum of 5 comma 6? It's 5. Means rank of this given matrix is that is equal to 5 or less than 5. You can remember, the rank of A that is less than or equal to minimum of this m comma n. We take minimum of this 5 comma 6. Which one is minimum? 5. So therefore rank of A is less than or equal to 5. Next one, the rank of identity matrix. rank of identity matrix is nothing but determinant of identity matrix is not equal to 0. So therefore rank of matrix is the order of that matrix, identity matrix. Suppose we take 1 0 0 1. So this is the identity matrix. It has two non-zero rows, or we check determinant of this matrix is not equal to 0. So therefore the rank of matrix is 2. What is the order of this? 2. So therefore rank of identity matrix IN is n. Okay. Next, the rank of product of two matrix means rank of A into B, which is less than or equal to rank of minimum of rank of A comma rank of B. Suppose we have two given matrix A and B. So what about rank of A into B? If we know the rank of A is 3, suppose rank of B is 4. So what is the possible rank of A into B? So that should be less than or equal to minimum of 3 comma 4. Means what is the minimum number? 3. So therefore rank of A into B, that should be less than or equal to 3. So next, rank of transpose of any matrix. Rank of A is always equal to rank of its transpose. Means rank of given matrix and rank of transpose of that given matrix should be equal. Is it clear? So this is the one of the definition of rank of matrix. We can define by using determinant. Let R said to be the rank of matrix whose determinant is not equal to 0, but the matrix submatrix of order R plus 1 that should have determinant is equals to 0. Next is echelon form. What is echelon form and where we use the echelon form? So echelon form is generally you can find out by using to find the rank of a matrix. Rank of a matrix is nothing but to number of non-zero rows in the echelon form. So that is the definition of rank of matrix. What is meant by echelon form? A given matrix is converted into the echelon form is nothing but that satisfy these 5 conditions. What are the 5 conditions? A matrix A is said to be the echelon form if all non-zero rows of any precede the zero rows. So you can remember this nothing but you can arrange the number of non-zero rows upside and 0 rows downside is nothing but 0 rows are the bottom of the matrix. So this first condition is non-zero rows are precede the 0 rows is nothing but you can write first non-zero rows, then bottom of the matrix you can write the 0 rows. So what are the 0 rows, what are the non-zero rows, how we can identify? 0 rows is nothing but all the elements in that row all are 0. Suppose this is a 0 row, this is non-zero row, this is non-zero row, means this row having all elements are 0, that nothing but 0 row. Is it clear? Next condition, the number of zeros preceding the first non-zero element in the row should be in ascending order. What is this condition is that number of zeros preceding the first non-zero element in row should be in ascending order. So this is second case. So what is first non-zero element in this? So this is the 0 row, no tension. Suppose this is non-zero row, this is the first non-zero element. So this is the first non-zero elements. How many zeros before this non-zero element? 0 element, there is nothing. Okay, here 1. You can arrange ascending order means 0, 1. This is in the correct order. Okay, you can check here. Here number of zeros before this leading element, nothing, 0. Here these are the 0 rows. Okay, what about this? How many zeros in this? This is a non-zero element, leading element. How many zeros? 1, 2. Here 1. So this is in the wrong order. You can arrange this in the ascending order means first 0, 1, 2, 3 like that. Number of zeros, you can count the number of zeros before the first non-zero element. First non-zero element that should be in ascending order. Ascending order means first we take lowest, then increasing order in terms of increasing order. Okay. Next, third one, using row transformation matrix can be converted into the echelon form. You can use this given matrix, convert into the echelon form. You can use the row transformation. What? Row transformation. Okay. Next, rank of A is nothing but the number of rows. What? Number of rows. We can find the rank of matrix by using the echelon form. You can count the number of non-zero rows. Next, all entries below the leading entry are 0. So what is the leading entry? Leading entry is nothing but that is the first non-zero element in the row. So that is called as leading element. So what is the leading element here? 1. Here 1. Here leading element 1. Here leading element 5. Here 2. Here 1. Okay, you can convert this given matrices into the echelon form. So what is the first condition? You can write the 0 rows bottom of the matrix and non-zero are the upside. Is nothing but, so this is a 0 rows, you can write bottom of matrix. Okay. Next, non-zero 1 0 2. Next 0 1 3. So what are the zeros before this? 0, nothing. Here 0 1. These are the all zeros. Means this is the in the echelon form. Echelon form. So how many non-zeros in this? This is a non-zero row, this is non-zero row, this is a 0 row. So therefore the rank of matrix is 2. For this example, rank of matrix is 2. Similarly, you can convert this into the echelon form. Here 1 2 3 all are 0. You can arrange bottom of the matrix. Then these are the 0. You can write like this. Next 1 2 minus 1. So this is in the echelon form. How many 0 rows? Non-zero rows? Only 1. So therefore the echelon rank of matrix is 1. The rank of matrix is 1. Similarly, you can arrange this one. So how many 0 rows? Nothing. All are non-zero. You can arrange in ascending order. So shall I write this as a first 2 4 minus 2 2. So no 0 before this. Here 2 zeros, here 1 0. So which one is first one? You can write this one because it having only 1 0 before the non-zero entry. So 0 1 1 4, and this is 0 0 5 8. So this is a rank of matrix is here. You can write non-zero rows is nothing but 1 2 3. Convert this given matrix into the echelon form by using the row transformation. Okay, let us start the examples. First example, convert the given matrix into the echelon form and find the ranks. What is question? Convert into the echelon form and find the rank of A. So let us consider A 1 3 4 3 3 9 12 9 minus 1 minus. Always you can convert this first element is 1, because by using this one you can easily convert the remaining elements are 0. Okay, so how to convert this 3 convert into 0? So you can using row transformation. What is the element? This is in the R2. So this is R2, this is R1, and this is R3. Let I consider R2 convert into R2 minus, how many times this 3 becomes 3 minus 3? 3 minus this 1 into 3 means 3 R1. So what we get, can focus on this, can make this 3 0. 3 1 3 4 3. Here 3 ones are 3, 3 minus 3 0. 3 3s are 9, 9 minus 9 0. 3 4s are 12, 12 minus 12 0. 3 3s are 9, 9 minus 9 0. So these all elements are 0. Next convert this into 0. So how to convert this one? R3. We change in the R3. R3 changes. R3, how it becomes 0? Plus 1 minus 1 means adding R3 plus R1. Minus 1 plus 1 0. Minus 3 plus 3 0. 4 plus 0. 3 minus 3 0. This is a very simple example. How many number of non-zero rows? Only 1 is the number of non-zero rows. So therefore rank of A is equals to number of non-zero rows. How many non-zero rows? Only one. So therefore rank of A is 1. So this is a required echelon form. Next example, convert this matrix into the echelon form and find the rank of this matrix A. So let us start. A is equivalent, you can give this symbol. So we have already 1 is there, so we can convert this into 0. So what is the place of this? R2. You can write R2 changes, R2 minus 2R1 means 2 times this one, 2 ones are 2, 2 minus 2, 0. Okay. So what we get? 1, 2, minus 1, 4. Here 2 ones are 2, 0. 2 twos are 4, 4 minus 4, 0. Here 2 ones are 2, means minus, minus, plus 3 plus 2, 5. Here 5, 2 fours are 8. 5 minus 8, minus 3 is there. Okay. Next I want this one is 0. R3 changes, R3 minus 1 plus 1, 0. Means R3 plus R1. Adding this 2. Minus 1 plus 1, 0. Minus 2 plus 2, 0. 6 minus 1, 5. Minus 7 plus 4, minus 3. So if possible, you can apply again row transformation. If not possible, you can find out the number of non-zero rows. Okay. Here it is clear that these rows are same. So rows are same is nothing but it is possible to this all elements should be 0. Means I can use again R3 changes, R3 minus R2. You can use this R2. By using R2, you can make this R3 0. Means here 1, 2, minus 1, 4, 0, 0, 5 minus 3. 0 minus 0, 0. 0 minus 0, 0. 5 minus 5, 0. Minus 3 minus of minus 3 means plus 3, 0. There is no possibility to make this two elements 0. So therefore, number of non-zero rows, this is a echelon form, number of non-zero rows are 1 and 2. So therefore, you can write here this is required echelon form. And what is the rank of A? Rank of A is equals to number of non-zero rows. So that are 2. So therefore rank of given matrix is